To handle a problem like number 1, you need to be aware of the link between the pH scale and strong and weak acids and bases. So let's take a look at the pH scale. So we've got the pH, and we can go say 1, 5, 7, 9, and 14. And I'm just going to abbreviate these. So this would be a strong acid. This will be a weak acid. This will be neutral. This will be a weak base. And this will be a strong base. So what you're told in the problem is what you're dealing with, and in this case it's a weak acid being titrated with a strong base. So what you would do is, you're going to have a list of these. There's going to be, I can't show them all on this screen, but there's a whole bunch of these diagrams here, and they're all set up in a certain way with pH on the y-axis and volume of something on the x-axis. So a couple of things to be concerned about. First of all, if you're dealing with any titration, then the situation is going to be that you're going to start with a burette, which that'll be the burette. It's not a very good burette, but it's a burette. And there's a flask there. So in here, for example, this would be the weak acid. So it's going to be in the flask, and the strong base is in the burette. So we know initially that down here it's going to be volume of base because that's what's in the burette. So this is what we're going to be expecting, volume of base down here. Over here we're going to have pH, and we're told here we're starting with a weak acid, which is what's in the flask. So we know that if we go ahead and write down some numbers here, we'll do 1, 7 and say 13, that the pH, starting pH is going to be 5 because it's going to be a weak acid. So that's going to be the starting point of our curve. And we're doing it with the strong base, which means that the ending pH is going to be up here at the 13 level, which represents a strong base. The reason I'm doing 13 is because 5 and 13 is 18, divided by 2 is 9. Just makes it a bit easier for me to find the equivalence point. Whoops. Let's try that again. There we go, that's better. So that's what the curve will look like. Now the next thing we need to do is figure out if we're going to be dealing with a buffer region or not. Now the definition of a buffer is one where you've got an addition of a strong acid, where you've got a weak acid or base and it's being titrated with a strong acid or base, obviously the opposite of what you have in there. You can't titrate an acid with an acid, for example. So it's either a weak acid being titrated with a strong base or a weak base being titrated with a strong acid. So what's going to happen in that instance is you'll end up with a mixture of a weak acid and a weak base in the solution. Now the reason for that is because if you start off with a weak acid, I'll do a little diagram over here, and there we go. Let's just say we've got 2 AHs in there, and then we add in a strong base like OH minus, for example. What's going to happen is the AH is going to react with the OH minus, and we're going to be left with A minus and AH. Because that's a mixture of a weak base and its conjugate acid, that's going to equal it being a buffer. So that's always the way that it goes. whenever you've got a weak base and its conjugate acid, that means you've got a buffer solution. This will only happen upon the addition of a strong acid or a strong base. So in this instance here, we are indeed adding a strong acid to a strong base to a weak acid. So I actually would expect the buffer region. Now the buffer region is going to be here. Sorry about that. For some reason I'm having trouble writing the word buffer here. Let's try that again. There we go. So we've got a buffer down here. And the reason it's a buffer is because there's going to be only a small change in pH. As the strong acid or base gets added, in this case, the strong base. And that is going to result in a fairly flattish region here, because the pH isn't going to change much, at least for a little while, until it gets until the acid gets completely neutralized. Then you'll see this big jump, and then it'll go up to the pH of the strong base that you're adding. So in this case, this would be the diagram that I would be looking for. One that starts at 5, ends at 13, and has a buffer region down here on the flat part of the curve that we're seeing at the beginning.